Welcome to Unit 8, Lesson 3, where we will learn about the different measures of spread. Before we start defining spread, let's look at a warm-up problem that shows us how it works. We're going to look at the test scores for two different classes on the last algebra test. We're asked to find the median of each class. After finding the medians, we notice that they are the same. So according to our measure of center, the median, there's not really a difference between the typical value of these two data sets. But we're asked which class do we think performed better. If we look closer at the data values, we'll notice that Class A has a lowest score of 74 through a highest score of 93. So every student in the class got a C, B, or A on the test. And now Class B had more 100%, but also had a few students that failed. So even though the typical data value, the median, was the same for each data set, we notice that the two classes have some pretty stark differences. And we can start describing these differences using the concept of spread. While we've already talked about the concept of center throughout this unit, another key characteristic of a data set is its spread. This describes how bunched up or spread apart the data set is. In this lesson, we're going to learn about three measures of spread: the range, IQR, and standard deviation. The simplest way to tell how spread out a data set is the range. We can calculate this by taking the largest data value minus the smallest data value for the given data set. For our first example, we see that the greatest value is 41 and the smallest value is 1, giving us a range of 40. This calculation is very convenient because it's quick and easy to calculate. The concern with this method is if we had an extreme value. Imagine we had a data set that was very closely bunched together, but then had one outlier value at the end. This extreme value would make the range look much larger than it actually is, as you see that almost all the data values are within 2 units of each other, and there's just one data value that's extremely far away. So we'll sum that up by saying the concern with this measurement is that it can be misleading if you have an extreme data value. There's a more sophisticated way to calculate spread called IQR, but in order to learn this, we're going to have to start with a concept called the 5-number summary. For a given data set, the 5-number summary is the least value, the first quartile, the median, the third quartile, and the greatest value of the data set. The new word here is quartile. What a quartile is it's the median of the first half of the data set or the second half of the data set. So we'll have our median of the entire data set and then 2 mini medians for each half of the data set. This will make a little bit more sense when we see an example. So here's the data set we're going to work with. I'm going to put it in numeric order. Now that it's in numeric order, it's easy to find the LV and the GV. The least value is 1, and the greatest value is 7. Just like we did in our measure of center lesson, we're going to find the median, counting to the middle. Since there's 10 data values, our median is going to be between the 5th and 6th data value. Since these values are 4 and 5, our median will be 4.5. And we'll put that down here in our 5-number summary. And now what the median has done is it's cut the data set into 2 halves, a first half and a second half. Our quartiles are going to be the medians of each of these halves. So since there's 5 data values here, the third data value would be the median, or in this case, our first quartile. And since there's 5 data values over here, the middle data value being 6 will be our third quartile. And these 5 numbers down here are called our 5-number summary. This summary has multiple applications. In this lesson, it's going to be used to find our next measure of center, and in the next lesson, it's going to be used to construct a statistical graph called a box plot. Now that we know about the 5-number summary, we can calculate the next measure of spread called the interquartile range, or IQR for short. The interquartile range is the distance between the first and third quartiles. This gives us a really easy formula of Q3 minus Q1. The value of this versus range is we're using data values from the middle of the data set, which aren't going to be affected by extreme data values on the ends of the data set. In order to find IQR, we're going to start by finding our 5-number summary. This data set's already in numeric order. So 0 is going to be our LV, 45 is going to be our GV, and since we know there's 11 data values, the middle one will be the 6th value, 8. That's our median. Now remember, the median cuts the data set into 2 halves, each with 5 numbers. The middle number from each of these halves is our quartiles. So in this case, it's 4 and 14. And this gives us our 5-number summary. Now to calculate IQR, we're just going to need Q3 and Q1. So we'll subtract 14 by 4, giving us an IQR of 10. Now if the IQR of one data set is larger than the IQR of another, That means it's more spread out because the distance between the Q3 and Q1 is greater if the IQR is larger. A cool application of IQR is that we can use it to determine whether or not a given data value is an outlier to the data set. We got to start by defining what an outlier is. An outlier is a data value that lies outside of the typical range of the data values. This could be a data value that's extremely low or extremely high compared to the other data values. To determine whether or not something's an outlier, we can use the following formula. This will give us a range of numbers that are typical. Any number that's outside of that range would be considered unusual, and we would call it an outlier. This formula is found by taking the first quartile and subtracting 1.5 times whatever the calculated IQR is, and then taking Q3 and adding 1.5 again times whatever the IQR is. Let's use this formula to complete example number 5, where we're asked to construct the outlier range for this data set. Since this data set's already in numeric order, I'm going to start finding the 5-number summary. I can start by labeling our LV and our GV. Since there's 12 data values, the median will be between the 6th and 7th data value, or 52.5. And this median will cut the data set into 2 halves. The middle of the first half would be 49, which would be our Q1, and the middle of the second half would be 57.5, or Q3. This tells us that our IQR is going to equal Q3 minus Q1, or 57.5 minus 49, which equals 8.5. Now for the outlier range. I'm going to start by just writing out my formula, and then I'll plug in the things I know. So I've plugged in my Q1 and Q3 and my IQR. I can simplify this using my calculator to see that the first number is going to be 36.25 and my second number is going to be 70.25. Now that I have this range, I know that any number smaller than the first number or larger than the second number would be considered an outlier. Since 62 falls between these two numbers, it is not an outlier. And since 12 is smaller than the first number, it is an outlier. It can be very important to know whether or not a number is an outlier when we're considering our data set, and this range gives us that ability. Finally, we're going to talk about the measure of spread called the standard deviation. In this class, we're not going to calculate the standard deviation, but it is the most sophisticated way to measure the spread throughout a data set. Just like IQR and range, the larger the standard deviation, the more spread out the data set is. The lower the standard deviation, the less spread out it is. In example 6, we're going to look at a statistical graph called a dot plot. For this problem, we're comparing two schools, school A and school B. And for each data value within the school, we've put a dot representing that data value. So you can see that there's one student with a 2.0 GPA, two students with a 2.0 GPA, four students with a 4.0 GPA, and the pattern follows however many dots are above a number is how many data values fall in that range. So we can see that school A's data set falls between 2 and 4, is pretty tightly bunched together, where school B has a much wider range all the way from 0 to 4. Since school B has the larger spread, we would assume it has the higher standard deviation. So when we're asked which school would have the lower standard deviation, our answer would be school A. And for now in this class, that's all we're going to do with standard deviation. We're going to estimate which standard deviation value would be lower or higher based on some other information. Our next question asks, if we took this 2.0 for school A and we moved it to 0.5, how would that impact the standard deviation, range, and IQR? Well, since 2.0 was the smallest data value for this set, moving it further away is going to make the data set more spread out. If there's any change in how spread out the data is, the standard deviation will always change. So since that data value is getting further away, spreading out the data set, the standard deviation would go up. Similarly, with the range is found by taking the largest data value, 4.0, minus the smallest data value, which was 2.0 but is now 0.5. Since 0.5 is further away from 4.0, the subtraction is actually going to result in a larger number, meaning the range went up. Now what's interesting with IQR is that IQR only deals with the middle part of the data set. So changing a data value on the outside is actually not going to affect the IQR. If you change the data in the middle of the data set, that would actually have an impact on the IQR. This further illustrates that both standard deviation and range could be impacted by extremely large or low values, known as outliers, where IQR is a little bit more reliable because it won't be affected by an outlier. Our final problem, example 8, asks us to look back at that warm-up problem we had earlier. They tell us that Class A had a standard deviation of 5.3, and they want us to estimate the standard deviation for Class B. Well, we notice that Class A is less spread out, where Class B is more spread out. So if we know the standard deviation for Class A equals 5.3, we would expect Class B's number to be higher. So when we're asked to estimate, just give any number larger than 5.3. I'll say 10. And for now in this class, that's all we're going to need to be able to do for finding that value for S. To summarize this lesson, datasets can be described using measures of center and spread. In this lesson, we learned about the measures of spread called standard deviation, IQR, and range. In general, if a dataset is more spread out, its measures of center will be larger. If you came away with anything else in this lesson, write that down now. Otherwise, we'll see you in the next lesson.